All right, hello everyone. Welcome to some special right triangles. In this video, what we're going to be doing is we're going to be solving for missing values in right triangles. And when we do this, we have two different ways to do it. The first way is with a 45, 45, 90 triangle, which is going to be the first video. And then we also have with 30, 60, 90 triangles, which will be the video that follows after this. So we're going to take a look at these two special cases with right triangles. By the end of this lesson, you will be able to solve for missing triangle measures with 85% accuracy. Here are some important things that are important definitions that we're going to need to know. We're going to specifically focus on the special right triangle, hypotenuse, and leg today. So the question that we need to answer is, how do we determine the best method to solve for a given triangle? So we're going to take a look at our first case, which was the 45, 45, 90s. In 45, 45, 90 degree triangles, what we're looking for are specifically two angles that are 45 degrees. So here's one, here's two. So these two angles are 45 degrees. And then of course we have our 90-degree right angle. So this is why we can use, or why we can say special right triangles, because we have two special angles here. They're both 45 degrees, and then it's also a right triangle. Okay, so a lot of this just comes from a square. Right, with a square, if I extended this out like this, okay, this other side over here would be 45 degrees, which makes this 90. So in a square, when we find the diagonal piece, okay, there's a special formula that we use, which is the x square root of 2. So if you have a 45, 45, 90 triangle, then we can use these formulas here to help us solve for the missing sides. Now, it's important to note that, okay, you must identify the hypotenuse and the legs first. Okay, so that's the first thing that we need to do. First thing we need to do is to label our picture. Label, label, label. Label our picture. So when we do this, okay, we're first going to identify where the hypotenuse is. Okay, so this should be a review for you. The hypotenuse is across from the 90. Hypotenuse is across from 90 degrees. So if I come here at the 90-degree angle and I just draw an arrow that goes straight across like this, that is where my hypotenuse is located. Okay, hypotenuse here, sometimes you'll see it as H, sometimes you'll see it as C, the side C in the Pythagorean theorem, right? A squared plus B squared equals C squared. That would be this guy right here. Okay, so here's our hypotenuse. We also have to identify legs. Okay, that's the second piece of special right triangles, identifying the legs. So here's the leg right here, and here's the other leg. There's two legs, always two legs. Okay, the legs are adjacent to the 90-degree angle, or they're next to. Adjacent means next to. They're going to touch the 90-degree angle. So our legs here are in green. Now with the formula, the leg, in this case, okay, the leg, the formula for it is going to be x. Okay, so that's what this x is here. This is our formula for the legs. Okay, another way that you can think of the legs is that it's the hypotenuse divided by the square root of 2. Because to find the hypotenuse, we take one leg. Okay, so we take one leg, which is just, in this case, x. X is just representing one leg. And then we attach the square root of 2 with it. So we're multiplying one leg by the square root of 2. Okay, so if you're given a leg, okay, to find the hypotenuse, you would take one leg, whatever number that is, multiply it by the square root of 2. If they give you the hypotenuse, then you would divide by the square root of 2 to get your leg. Okay, so these are just some of the formulas that you're going to need for special right triangles that are 45, 45, 90. Okay, let's come here and take a look at some examples. We're going to do a few of these together. The first one being number 1. Okay, so for number 1, we need to find two things. We need to find A, what does A equal? And then we also need to find out what B is equal to. So just like we said in the notes, the first thing that we need to do is identify where the hypotenuse is. So I draw my arrow straight across. Here's my hypotenuse. I call it hype. Okay, we get hyped about the hypotenuse. Right here in green, we have our legs. Okay, so one leg is equal to 2 times the square root of 2. Since both legs are equal to each other in 45, 45, 90s, that means that I can take this value here and plug it in for B. So B is also going to be 2 times the square root of 2. Okay, this is how I want it written out. You don't need to multiply these together. We're keeping everything in simplest as radicals in the simplest form. Now for A, okay, this side down here in blue, to find A, remember what our formula said. The hypotenuse is equal to the leg times the square root of 2. So our leg here in this case is 2 times the square root of 2. And then we're going to multiply it by another square root of 2. Okay, so I'll rewrite this. I have 2, and then I have the square root of 2 squared because there's 2 of them. And what happens when we have a square root squared? That's right, you guessed it. These cancel out, and then you're left with 2. Whatever's underneath comes out. 2 times 2. This guy is going to be 4. There you go. Those are your sides for number 1. Okay, we're going to pause, and you can try number 3. All right, so we're back. With number 3, here is the work that you should have shown for number 3. All right, so we have all of our work written out here. The first thing that you should have done was labeled your picture. So here on the sides, we have in red our 2 legs. Okay, remember the legs. If you're given the leg by itself, oops, that's for the other one. The leg by itself is just equal to x, right here. So this leg is by itself. That means that y is going to be the same value. So y is going to be 3 times the square root of 2 divided by 2. Now for x, x is the hypotenuse because it is across from the 90-degree angle. Hypotenuse, the formula for that, we come back here, is equal to the leg times the square root of 2. Okay, so that's what's written here. And then I just replace my value for the leg, which is 3 square root of 2 over 2. I multiplied the square root of 2 in, and then just like we did in example number 1, we have 2 square root of 2's. Okay, so the square root of 2 gets written down. I put it in parentheses and then attach the squared symbol because there's 2 of them. Okay, remember a square is multiplying a number by itself. Okay, so now this cancels out. And what we're left with is 3 times 2 divided by 2. And since the variable for the hypotenuse is x, I replace the hypotenuse with x and set that equal to 3 because that is what was simplified. So what we need to come over and do next is an example over what to do whenever we are given the hypotenuse, but not any of the legs. So let's go ahead and take a look at one of those. Okay, I'm going to do number 6. Okay, so we know that our hypotenuse is across from the 90-degree angle. Okay, so that side is going to be listed in green. I'm just going to write it up here. Hypotenuse is equal to 2 times the square root of 6. Now for the 2 legs, okay, those are going to be down here because they're adjacent to the 90-degree angle. So I put a leg here, put a leg here. And remember, our formula from the previous slide says that a leg is equal to the hypotenuse divided by the square root of 2. Okay, so anytime that you're given the hypotenuse, this is how you're going to solve these kinds of questions. You're going to take what they give you. Okay, so in this case, it's 2 square root of 2. And then we're going to divide this by the square root of 2. So the way that my work's going to be written out, it's going to look like this. I have 2 square root of 2, or I'm sorry, square root of 6. 2 square root of 6 divided by the square root of 2. And this is one of the reasons why we went over radicals so much in the beginning of this unit. Okay, because we have to know what to do in this situation right here. Okay, so what do we need to do to get rid of the square root of 2 on the bottom? We have to multiply by the square root of 2 over the square root of 2. Okay, this did not change the problem. But what I do need to do is simplify this a little bit further. So the 2 on the outside is going to stay by itself. And then since both the 6 and this square root of 2 are underneath the house, okay, I'm going to put them in there together. So I have 6 times 2 underneath. And then on the bottom, the square root of 2 times the square root of 2, that just cancels itself out. And it leaves us with what's underneath, which is a 2. Okay, so we simplify a little bit further. These cancel out, 2's. And then the leg is now equal to the square root of 6 times 2, which is 12. Okay, now we can simplify the square root of 12. So to do that, we're going to come up here. And this is where the prime factorization comes into play. If you wanted to use your Desmos calculator, you could do that as well. Okay, but remember, we want everything as radicals in simplest form. Okay, so with 12, if I break this down into the prime factorization, I'm going to divide by 2. And then 6, I can divide by 2 again and get 3. And then I can pull a 2 out from underneath the square root. Okay, what's left is the 3. The 3 stays in the house by itself, and this is what my leg is equal to. So for this problem, both x and y are equal to 2 times the square root of 3. Okay, now I want you to do number 2 by yourself. All right, so here's our shown work. Okay, right up here at the top, this is the formula that we are using here. It's the same one that we used in the previous example. Remember, anytime that you're given the hypotenuse and no legs, what you're going to do for the 45, 90s is use this formula right here. So we take our hypotenuse, just 4, we plug it in up here, divided by the square root of 2. And just like in the previous example, okay, we can't have radicals in the denominator. So I multiply by the square root of 2 over the square root of 2. That cancels these out and leaves me with 1, 2. And then on the top, I have 4 square root of 2. 4 divided by 2 gives me 2. And then both of the legs are equal to 2 times the square root of 2. All right, so that's it for the 45, 45, 90s. In the next video, we will be talking about 30, 60, 90s.